got planned right now, and that is JavaScript day 3. This is the hill in the week, and then we're going to go downhill into more consumable and I think fun context tomorrow. So tomorrow's going to be a lot more lightweight. So we're at the top of the hill, and we've summited JavaScript Fundamentals Mountain today. You're going to feel it. You're going to feel the burn, but it's going to be good. So in this case, we're going to be talking about the 4 principles of the this keyword and demonstrate their uses. We're going to be able to describe and use prototypes, constructor functions, the new keyword, and pseudo-classical inheritance, to build a small object-based video game. That's right, you're going to be building basically a little text-based RPG this afternoon. It's going to blow your mind that you can actually do it. It's pretty cool. So first off, hopefully you watched the videos, got some introduction to the concepts today. I want to highly recommend that you watch the Tyler McGinnis WTF is this video after lunch, okay? After lunch. So put this on your must-watch list. It's in the prepare section on purpose. So hopefully you've already watched it one time. But this is gold, this video. So after you've been exposed to it, watching it again is going to just be that much more helpful. All right. Without further ado, this is a guided project, so we've got to start talking about actual code. So HTML and CSS, we don't need you right now. We'll talk about how we integrate those things next week. But this week, it's all JavaScript, right? So first off, I want to start off, as I usually do, with some kind of analogy or something fun. In this case, I just need to get a picture of some trees. Here we go. So given this forest of trees, beautiful trees, if I was standing right here at this vantage and you were all behind me, and we were doing an object lesson out in the forest right now, I would say, tell me about that tree. And you'd be like, what? Which tree? I'd say that tree. And let's say I wasn't pointing anywhere. You'd be like, what are you talking about? I'd say that tree. And you'd be like, okay, this is stupid. What's going on here? And that's kind of the first principle of the this binding when it's referring to the window. So the window in JavaScript is like a tree inside of the forest. Like we don't know which one we're pointing to, so it always defaults to the forest. So the window binding is the first binding rule we're going to talk about. And I like to think of it as the forest. So if I'm like, look at this, well, I'm actually looking at the whole forest. So let's go see what that means. That was JavaScript 2. This is JavaScript 3. Okay. So in this case, we have the JS3 guided project for web and this keyword. Hopefully you're all seeing the same thing. And we've got to look at the window binding. So first off, I think a great exercise is just everybody, let's do this together. Console.log, type this with me. And let's just put the this keyword, and let's see what the heck it is. So I'm going to go over here and change my settings so I can auto run it and everything. So notice it says log is skipped. It's too big for CodePen's console. So I've got to be able to inspect my element, right, and look at the real console. So if I refresh this page and hit run, let's just get it down here. So looky here. This keyword is pointing to window. And window is quite literally everything we're looking at right now. Look at this. This is bonkers. How much is on this object? Wow. Remember how we made our animal object on Monday? This is not, we're not in the animal object anymore. This is crazy how much going on in the window. So this is quite literally, without any other rules applied to it, the forest. So I want you to think of window as being this whole forest that we're looking at. So that is the this keyword. It's basically saying, well, what do you mean that? And if it doesn't know exactly what you mean, it says, well, you must mean the forest, right? So that is what I like to think about with the window binding. So I'm going to talk about window binding is like the forest of trees. Not sure which one we are pointing at. So we point at the forest. And so I want you to think about it in that context. It's really helped me understand that this keyword more is like, well, if you don't have anywhere you're pointing, it must be the whole forest. So let's talk about how this looks inside of a function. So I'm going to comment this out. Okay, you don't have to follow along anymore. Just pay attention. So I'm going to say function, and I'm just going to make a simple function declaration and say hello, open and close, and just get this thing going. I'm going to receive a parameter. We'll just call it param. And I'm going to say console. I already got it. Let me bring it in here. We'll bring that back in. We've got to invoke the function, right? So I'm going to say console.log. And then I'll invoke hello, and I'll pass in a parameter. So I could say, you know, a name or something. So I could say hello, web19. So in this case, we could just receive a name. And maybe I'll say like return, return. And I'll just say hello, and then name. All right, where am I? There we are. So in this case, right here, I could say hello, web19. Let's see what pops out. So I'm going to hit run. And you can see it says hello, web19. So web19 came through the parameter, and then I interpolated it with my string template literals in my return statement. Wow. So in this case, we've now got name. Now here's the thing. I'm in a function. I'm in a new scope, right? Like I've got a scope here. So could I actually change something here that I could use the this keyword inside of here? Could I say this.name, for example? If I'm looking at the function here, like does this make sense inside of here to say this.name? What do you think? When you see that, what goes through your mind? When you see this dot. So Zach's saying global. It's going back to the global scope because it's not an object. Aha, very good thinking here. So let's try this out though. Let me get rid of that, sorry, and just say this.name. Let's see if that changes anything. I'll keep the before, and then we'll hit run to see the after. Hello, CodePen. What? What the heck? So how did CodePen show up in here? Well, guess what? CodePen actually has named their window object. So that's the reason why this works. If we were in any other environment, it wouldn't say CodePen. It would freak out. So in this case, CodePen has actually set the name, which I always think is funny. But it's kind of interesting to see, right? Like it's pointing to the forest. So in this case, the forest is CodePen. It's like the whole app CodePen. So this.name is not really useful in this environment because guess what? It always tries to go to the window. So what if we wanted it to not go to the window? Well, let's try out, we can use something called use strict. Let's see what this does. So use strict was a way for us to literally write the weirdest looking syntax we've probably seen in JavaScript. There's no variable or anything, it's just a string. And use strict basically says, hey, don't bind to the window. Keep everything inside of this scope limited. So let me hit save and run. Let's see the difference here. Nothing. So if I go look at the console here, you can see cannot read property name of undefined. So use strict prevents functions or any kind of block of scope, by the way, anything inside of curly braces from jumping up to the window binding on accident. So a lot of developers use this a lot of old school developers, I should say, because usually new school developers are using something like Webpack, which automatically applies use strict to every function anyway. But if you don't have some kind of tool automatically doing it, you can prevent the accidental window binding by forcing it to never go past these curly braces. So use strict is a great little tool if you're not using some kind of bundler, which you'll understand that later down the road. Like I don't expect you know what that means right now. For now, understand use strict is preventing us from pointing to the forest. It's as if somebody's saying, which tree? This doesn't make any sense. And so that's what this error is saying, is like, this doesn't make any sense. Like, you've got to have something that makes sense here. So this is a good behavior. Errors are good. I want you to understand that. Errors are so good because they tell you that there's something wrong. If you don't have errors and it's just working, well, then you get hello code pen. That's not something you want. So keep that in your back pocket whenever you're thinking, I don't have any errors and nothing's working right. Like, that's a bad thing. You want errors to tell you what's going on. Okay, so the window binding always tries, so this keyword always tries to point to the window in any function it can. And it goes to objects as well, I should say. So in any time, in any place, it's always trying to point back to the forest. So if we can prevent it by using strict, use strict prevents us from accidentally binding to the window. And usually you have to put it at the top of the function scope. Okay, so really, you know how I usually start with a non-example or something. Don't do this. Window binding is not good behavior. Like, you don't want to bind to the window. I can't think of instances where I needed to bind to the window. But you need to know about it, just like you need to know about important, right? Like, you need to know about those things because they will bite you in the butt later if you didn't. So that's why we've got to learn about window binding. Okay, that is window binding. That is the first principle of the window, or sorry, of this keyword. So let's move into another principle, which is called implicit binding. Let me see if there's any questions on window real quick. How do you know when to use class.prototype function versus this dot function? We will talk about that in the second hour. So we'll talk about that. I still see use strict on gulp files. Can you explain why for a real world example? Yes. So gulp files, that means that they don't want to have any accidental bindings and they want to follow an even tighter set of rules. So this is just them being really good with their code. I like use strict, by the way. Like, it's really good. And for a long time, like, you'd go to JavaScript conferences and there were shirts everywhere that said use strict. Like, it was a huge thing for a while in the community until we started to get bundlers that could just do everything for us. So global and window binding are the same. Well, I want you to be sure that you understand that it's actually binding to the window object. That's different than the global scope. So global scope is anything can be viewed, right? Window binding is specifically binding this keyword to the window. So just be clear on that. Global is different than window. Why use strict in closing in print in quotes? That is the, oh no, I'm not the standards committee, but that's just the rules. Sorry. Okay, that's just the rules. That's what they told us to do. So in this case, let's look at the next thing, implicit binding. And whenever I hear the word implicit, I want you to think automatic. In this case, it's with objects and methods. And remember, methods are just functions inside of objects. So implicit binding is going to be another rule of the this keyword. So within implicit binding, let's go back to the forest here and let's think about this. So let's say we're back in the forest, I'm past the window binding example, and I actually use my arm and I point to a tree. And I'm like, I want to go look at that tree. Let's everybody go to that tree. And because I'm pointing at the tree, everybody automatically knows exactly which tree I need to look at. And we all go gather around the right tree. And so in this instance, if I were to draw a square, I'd say, let's go to this tree right here. Then you would go, okay, cool. We'd all gather around that tree. So that is the same kind of concept when it comes to implicit binding. We're using a pointer. We're using something that's unavoidable. Like, it's like you can see where I'm pointing. So we're going to do the same thing now. So I'm going to make a Hobbit object because I'm a nerd and I like that stuff. And we'll come in here and I'm going to make one of my favorite Hobbits, Samwise Gamgee. So we got Samwise. And I don't really know his age. I'm not an expert, but we'll just guess on things. I know Sam likes taters. And Sam also likes to cook. So in this case, we'll set up a function for cooking. And then we'll say return. We'll use our string template literals. We'll use our $sign to escape out. And we'll say Samwise. Well, we'll start with just like a hard-coded string and see how we can get better. So Samwise loves to cook taters. All right. So in this instance, we then say console.log hobbit.cook, right? Let's see if this all works. Save and run. Samwise loves to cook taters. Awesome. So the problem with this, and by the way, we did this with the zebra example on Monday, but it was so hard coded that like it was not reusable. It was like this. This is not reusable code. Samwise loves to cook. What if I made another hobbit and I made, Frodo? And, we'll even keep taters. It doesn't matter. But I'd have to come in here and I'd have to manually change this. So this method is not reusable, right? So that sucks right there. I'd have to like rewrite that whole thing. Well, what if I could just utilize the properties inside of the method? So if I go back to Sam here, could I do this? So I come in here, and I grab my $sign again, and I pop in name, and I pop in food. Do you think this will work before I hit run? Oh, there we go. Sam is 102. That's right. Forgot they were so old. Okay. No. Okay, let's find out. Clear, save, and run. Wah, wah. We get an error. So if we look at the error, which again, we celebrate errors, food is not defined. Wait a second. What about name? Why is name defined? Let's take food out for a second and see, why does name work? Ah, tricksy little code pen still has the name binding to the window. So that's why it works. So in this case, food does not work. Okay, we've got a problem here. We don't have context. We're looking at the forest again. So we've got to figure out which tree. This is where the this keyword actually starts to become really useful. So with implicit binding, you actually have to look at where you called your method. So in this case, we called cook right here. Where did we call cook from? Hobbit. So implicit binding states that if you called a method, that this keyword will be applied to the left side of wherever you invoke that method. So Hobbit is the left side of our invocation. Therefore, this keyword, the tree in the forest, has been identified as Hobbit. So now if we say this.name and this.food, this is Hobbit by rule of the implicit binding or automatic binding with objects and methods. So this is called implicit binding. So I'm going to hit save and run, and let's see the difference. So now Samwise loves to cook taters, and if we bring in Frodo, let's see what happens actually when we have two of them. Let me try to run it. It's going to freak out. So in this case, it's trying to find, we've got two hobbits. So we've got to think about something else here because Frodo and Sam are fighting each other. So we've got to come up with a new name here. So we could come in and say, new hobbit. And we're going to talk about how we can solve this problem later today. But for now, it's actually good to see that problem. So we'll come in here, save, run. And now we can see Samwise loves to cook taters, Frodo loves to cook taters, and of course we could change this to whatever, So this is implicit binding. We now know where the tree is by the very nature of the left-hand side. So I'll get rid of this. I don't want it to be a distraction. I just want to focus on our one Hobbit here. But in this case, cook is being called on Hobbit. Therefore, it is automatically bound to the context of the this keyword. So this dot name, this dot food, it's all inside of these curly braces here at the end of Hobbit. So that is pretty straightforward, right? Like, I like this. This feels good. It makes sense. It's like, oh yeah, wherever I called my method, that's where the this keyword is going to be. All right, I'm gonna hit save. Any questions on this? Technically, isn't the window binding still implicit? It seems like this will implicitly point to the most parent objects from reference scope. I mean, you could say it's automatic. Yeah, I don't disagree with you on semantic there. But I want to be clear that the concept of what we're talking about when we're saying implicit binding is when we're talking about methods and objects. So I like what you're thinking here, and you're not wrong. The window binding does automatically occur. So good thought there, really good thought there. But focus on the implicit binding being assigned to objects. My run button on CodePen is gone. That's because you don't have the behavior settings set up. So if you come over to settings, and I have auto updating preview and I turned it off, that's a setting that you can turn off and on if you don't want to run your, I don't like running it every 5 seconds or whatever it runs, because then you get errors while you're trying to teach, and that's not fun. Is this the only way to define food? Feels like there's another way. That is the only way. That is the only way for context from the method call. Why didn't it work on the new Hobbit? Because the new Hobbit, well, it did work on the new Hobbit. What do you mean? Oh, probably because when I did this, and I explained that. But these names are fighting each other because of their consts, right? So because I used a const here, it doesn't like it. So that's why I have to change the name. Okay, so implicit binding only occurs with objects, but not with functions, as we saw in the first example. That's right. But I'm going to show you how we can bind things next with functions. Could you go over again why food alone didn't work until we added this with the hobbits? Sure. Oh, there's Legos again. I forgot that was up. So in this case, as we look at food, the thing is, you have to understand, and this is new for our understanding, is these name value pairs, key value pairs, are not understood by this function. So this function, by nature of this new scope, well, I have my insert key on. So every time we see this new scope here, let me get this tool out. So right there and right there, we've basically entered a new kingdom, right? So don't forget our kingdom lesson. There you go, long live the queen. So in this case, we've got a new kind of mini landscape that belongs just to cook. So out here, everything is visible inside of these curly braces. But because we're not passing anything in, there's no parameters, right, in our function. We didn't pass anything in here. So that's actually totally disjointed. Like it's total, they're unaware. Like they're totally different worlds, just like we talked about yesterday. So in this case, this dot name and this dot food, without a method call here, would be totally unaware of the content up here. It's like they're different worlds, even though they're in the same Hobbit kingdom. So that's the crazy thing about functions, is functions introduce new local scope, right? So if we go to our debugger, throw our debugger statement in here, save, inspect, run. You can see we've got our local scope right there. And it's looking at this dot object, and it's grabbing everything that it can. But you'll notice that we've got food and taters, right? But it doesn't, it has to go off of this, right? So notice that there's a this object. So that's why we have to say this dot, right? This dot, this dot. Like that's actually that's really good. If I can hover over, I didn't know it did that. So as I hover over the this keyword, you can see what's available to it. Does that make sense? So the this keyword is holding all the stuff that came from when the object was invoked. So age 102, food, taters, Samwise, that's why we can access it. If we deleted the this keyword and we try to look at food, food is not defined. It doesn't know where the heck food came from. Because why? It's in the new function, right? The function has new everything in there. So that is why we need the this keyword. It carries a lot of information with it. As you can see here, that's actually really cool. I've never done that before. Really does help visualize the this keyword really well. Okay, so hopefully that helped. Are you able to use arrow functions? No. So arrow functions, arrow functions don't have a binding of the this keyword. So I mean, you can. Okay, let's go look at this. So if we come over here and we get rid of this and we bring in an arrow like that, let's see what happens. Save and run. So now if we look at the this keyword, where is it pointing? It's pointing back to the forest, right? Because there's no binding. So I told you we'd talk about it today. Let's talk about it now. The arrow syntax tells the compiler, don't bind any this keyword to me. Like there's no binding. It's not passing through. It's not like taking somebody else's this keyword. It has literally no binding. So when you use an arrow like this, it's trying to point up to, of course, the forest. It's trying to point to the window. So this is why we don't want to use arrow functions, because it just wrecks everything, because arrow functions don't bind to this keyword. Versus our anonymous function does bind to this keyword. So let me bring this back in and show you. So save and run. And you can see CodePen loves to cook undefined because those are both pointing back to the window object, right? So it's like, wow, what the heck? And that's because there's no binding here. It's disregarding Hobbit and it's looking right at window. So arrow functions are super dangerous in methods. Don't use them. So if we come in here, function, we regain our binding of the this keyword. You can see Samwise loves to cook taters. Great question. I'm glad you asked that because it allowed us to dig a little deeper there. Okay. Let's take our 5-minute break. When we come back, we will go into explicit binding for functions. 5 minutes. All right. Break time is over. Hopefully that little break helped wash this keyword over our minds. Help us focus a little bit more on the tree analogy, looking at one individual tree. So with explicit binding, it's more like we can force where the tree goes. So with implicit binding, it's like there's a tree, I point to it. Explicit binding is like, I want to go plant a new tree over there. So it's like way more control than what we've had with implicit. Because implicit was like, there's a tree, let's go to it. So for example, here's an object, let's go to it by calling the method. Now we're going to introduce explicit binding. And this is for functions. So like literally for functions. It's kind of nice to put these things in little containers. So implicit is for objects. Explicit is for functions. Window is so you don't use it. There's been some people that have been like, let's just take this binding off of window completely. Like nobody uses it, but there are, I'm sure, some edge cases that I'm not thinking of. But in this case, the explicit binding for functions is telling us where we want to go. So to see this in action, we simply have to write a function. So with our function, I'm going to do an introduction function. I've done this in the past. It's just nice and easy. And the introduction function, I'm going to go ahead and comment this out so we don't run into any collision issues. So with function introduction, I'm going to then say return, hello, my name is, I will say Josh, and I like to program in HTML, CSS, JavaScript. Okay. Excuse me. So in this case, I'm going to return a simple, hello, my name is Josh. I'm then going to invoke my function. So introduction, there's something, all right, I just can't spell. There we go. So introduction, and let's just get this thing working. Save and run. Something's up. So what happened here? I've got function introduction. I've got this thing running. Do you see any issues with my code? What's going on here? Why is introduction not working? See anything weird? Very good. Console log. Why? Why do we have to do that? Yeah, to print it. But why? Like, why is this not showing up? I'm looking for one specific thing. The return keyword, right? There you go. I just want to keep us on our toes, so we're always looking at everything. So on line 28, we've got the return keyword. We're not console logging, right? So that's why we've got to wrap it in a console log, because it's returning a value. Just want to keep us super fresh on our fundamentals always. So we hit save and run, and now we get it. Okay, so inside of our introduction, we know that we could pass in some parameters, right? We could come in here and say, well, name, it's going to be Josh, right? So we'll pass in a string. And then I could pass in HTML, CSS, and JavaScript. That's a lot of arguments, right? I could receive them all, come in here and say name, HTML, CSS, JS. But I'm basically writing a lot of code that I've repeated quite a bit here. So usually don't have spaces in my parameters. So then I can pop this stuff in here and swap it out, right? So I could say name, and then of course get each one of these values. HTML, see how laborious this is? It's pretty hefty to go through here and do all this stuff. Okay, So now we'll hit clear, save, and run. You can see my name is Josh. I like to program in, right? So I could change this to say, you know, Ruby, clean Ruby, hit run, and we get Ruby. Okay. So this is all fine and well, but what if we wanted to reference another object that had already been created? Let's say we had a person object over here. And let's say the person object had a name. Let's use JSON notation, so name like that. And we'll come in here and we'll say, you know, Ruby. Oops, don't need a semicolon. But in this case, let's say name and Ruby. So how could I get person to be understood in here? Well, could I pass person in? Person.name, okay. So in this case, we have a hard-coded Ruby. So let's get rid of these hard-coded values for a second. But we'll keep the HTML pieces in here. So if I pass in the person object, if I pass this in, and it's received here, could I do person.name here? That would work. Let's try it. Save and run. Hello, my name is Ruby, and I like to program. So it does work. That's pretty cool. The problem is, person, what if I wanted to pass in any object I want? What if I had another object? Well, then I would have to change the name, right? So something new. Then I would have to pass in a different parameter. So this stuff can be a little annoying. We can tell it where to come from, though. So yes, all of you are seeing why we could use explicit binding. And you're saying, hey, use this. And you're exactly right. So I've got this person over here. I've got name.ruby. This is too hard-coded, like just a person. We want this to be more open to any object that we want to pass in. And so we would prefer to say this .name. The problem with this .name, again, and why we talked about it very first, is what happens. It tries to go to the forest, tries to go to the window binding. So how can we force a function? Well, we can use function methods. So I'm going to go to MDN function, and I'm going to show you. Remember how to read the documentation, right? Properties first, methods second. And we have three methods here: apply, bind, and call. These three methods, that means every function ever has these, by the way. These three methods are all to do with the this keyword. So let's go look at call first. The call method calls a function with a given this value and arguments provided individually. Okay. Remember, look at the demo first and then kind of read it again. So they've got a function up here called product, name, and price. So in this case, this is a constructor function, which we'll talk about shortly. So ignore the new keyword. But what they're doing here is they're using the call method and they're passing in this keyword. So this example is very, man, this is probably an awful example as a new developer, because you're like, what the freak's going on with the new keyword? So in this case, I would say MDN failed us a little bit. So if we come back here and we try to call this out explicitly, it has to change when we invoke the function. So what I mean by that is we have to do this, .call. So remember, it's just a method. Just like console.log has a method, all functions have those methods. So call says what? What's the first property? If we scroll down here, you pass in this argument, so you tell it which tree. You are specifically saying, I want this new tree to exist, and then you can pass in n amount of arguments. So that means the first item is going to always be this keyword by nature of, like, this is just the rules on how to use this syntax. So if I come over here, the rules of using call are, this is this keyword reference, and then these are arguments. So let's see if this .name works now. Save and run. My name is Ruby, so that worked. and I like to program in CSS, JS undefined. What's going on here? So in this case, we passed in HTML. Do you see HTML anywhere? So it's coming in first. So HTML, HTML. Does anybody know what's going on there? Order, right? But if you look at over here, so optional arguments for the function, right? So if we come up here, they've got their call, and then they've got name, price, or whatever. So a method calls a function with given this value and arguments provided individually. So while the syntax of this function is almost identical to that of apply, the fundamental difference is that call accepts an argument list, while apply accepts a single array of arguments. Okay, so let's go see what that looks like. So we've got a list of arguments here. We've got HTML, CSS, JS. So first off, we have a problem. Name is sitting there, right? So good job, Hugo and Ruben, looking at the order. Name no longer is received, right? Why? Because the first argument is required to be this keyword, right? So it's implicit, it's automatic again, happening. So this is not necessary anymore because this keyword is pointing up here to Ruby by the very nature of call, and then the arguments are passed in. So if we save this and run it again, we should get the stuff we're looking for. There it is. Hello, my name is Ruby, and I like to program in HTML, CSS, and JavaScript. Okay. I got a space there, it looks like. So this is how we can explicitly bind using functions. Now let's go look at the other version, which is apply. So call lets us pass in individual arguments. Let's use apply. So if we go look at apply really quickly, you can see it looks pretty much the same, except there's a big difference. It accepts an argument list. Sorry, a single array of arguments. So if we come down here, it has this argument, and then it actually receives an array. Whoa, that's weird. So if we go over here, and we try to do the same thing, let's clear it, save it, run it. And you can see something's mad at us. So if we go look under the hood, it says, create list from array like called on non-object, meaning there must be an array there for apply to work. So it's looking for an array to be passed in. So what we could do is we could set up a new array, so const skills or whatever, assign the value of, and then we just throw this in an array. But it's interesting, right? You've got to have an array if you want to use apply, because it's looking for an array. So that's a big difference between call and apply. So we'll say apply needs an array if you want to pass in more args. I guess that's a single line quote, don't need multiple. And then call accepts individual args. So in this case, we have to pass in the array for this thing to even work. So let's say save and run. Okay, so we've got HTML, CSS, and JavaScript being passed in as a list of individual items. So this is going to be, apply is going to be more usable if we've got a chunk of data that we're trying to pass in. Call is going to be easier to use if we've got individual elements. So what if we put the array back in call? So what if we came over here, brought this in, and said, okay, let's put an array in here and see what happens. Save and run. So it's going to get the first item. It's going to think everything's in one big array, right? And then we get undefined, because it doesn't know what to do with CSS and JS, for example. And if we wanted this to be more like wide open, we could say, skills. 1, or skill, sorry, 2. I'm getting lost in my own array here. skill 1, skill 2. So like if we made this like way less specific to programming, we could put anybody in here with any skill, right? And then we just match it up. So 3 and 2. So that's just a naming convention. It didn't change anything, hopefully. So there we go. So I'm going to teach you something really cool. When we get to arrays, there's a thing called a spread and rest operator in JavaScript. So spread rest operator. So spread syntax allows an iterable, such as an array, to be expanded in places where 0 or more arguments or elements are expected. Or an object expression can be expanded where 0 or more arguments are expected. So oftentimes, as a developer, you will have n amount of arguments and you don't want to write 1,000 arguments or parameters. You just want to say, take everything I've got. Well, guess what? There is now syntax for that. This is new stuff with ES6 Plus. And it looks like this. It's really deceivingly simple. It's just the 3 ellipses, 3 dots in a row. That is signifying to the compiler that I want to spread out all of my values across every possible container. So what does that look like in our code? Well, it looks like this, ... It's tricky how simple that looks. But what that did is it spread all of the skills out, so HTML, CSS, JavaScript, into every possible parameter that could receive a skill. So let's run this again. And we should now see HTML, CSS, and JavaScript in their right place. That's pretty cool. So hypothetically speaking, if you know your spread operator, apply becomes obsolete. You don't need to use it anymore. Pretty cool. All right. So let's kind of review what we've done. Going back to the forest analogy, we're telling which forest or which tree to go into what spot in the forest with explicit. We totally control this keyword now. So we said, hey, this keyword is assigned to person. So this right here is referring to person. Then we have this dot name, which is pointing to person. So let me get my little drawing tool out here to point things around. So person is coming from up here. We're explicitly binding it to this function here. And so that's where this came from, right? So it came all the way back from Ruby. Then we learned that the arguments are passed individually. And I showed you a fun little trick with some syntax here called spread operator that allows us to take this array and spread it out into each individual skill. So yeah, this stuff maybe is a little too much for us right now, but it's freaking cool. And you do need to use it later on in your life. So take note of the spread syntax. Try it out later today. But in this case, this is how we got here. We explicitly bound it here, so we could use this, and then we passed in our skills. Okay, this is always to do with functions. So just remember, it's always to do with functions. All right, the last thing we're going to talk about with function binding is literally bind. So bind is used to save this keyword for later. So basically we can hold it inside of a variable in memory. So if we go up to bind, let's go back here, over here to bind. So bind creates a method, creates a new function that when called has this keyword set to the provided value. So it's like we can hold this keyword for later, which is super powerful. Talk about planting a tree in the forest. And so syntactically, it looks like what we were doing before with apply or call, I think. Yeah, it looks like call because it's allowing individual arguments. But again, you can use your spread syntax here if you want. So bind looks like that. You pass into this argument, but here's the difference. We can store it for later. So when I'm using call, I'm not storing it for later. I'm instantly calling it, like call. But bind can be like used, and I can say, well, do it later. Don't actually do it right this second. So here's how we can use, like, I'll call it use const. Use later, just to be really forward with this one. So use later, and then we could just say, just like we've got introduction, blah, blah, blah. So this time we're going to use bind. And of course, we can spread this out if we need to. So what this does is it says, look, I want to use this later, but I'll tell you when. So I'm just going to hold it. And then later on in a function, you could come in here and say console.log, and then you could run use later. You could say use later in this case. Let me get rid of here. The problem is I'm console logging a variable that has the introduction to bind, and we've got the return keyword in here. So how do you think we could get that one out of there? So we've got to invoke use later. So we save and run. We've seen it yet? We got a typo somewhere. There's an R in there. Okay, save it, run it. There we go. Okay, so basically, we're just holding on to this. We're not doing it until we invoke it later. This is going to be useful next week. So hold on to this thought. Don't let it mess with your brain too much. Just know that it's going to be coming later. Okay, so to review, functions need a this keyword bound to them. They innately try to go to the window binding. And so if we want to control where those function keywords are bound, we have to use call, apply, or bind specifically. And it's built right into every function. So these three functions. Okay? So that is the explicit binding. Again, this is the first introduction, hopefully this is like your second or third introduction to this concept. If you've not been watching the training kit videos, you absolutely should be. Also, this video from Tyler McGinnis is a must. Okay? Gotta watch this video. All right, so the last thing I want to talk about is the new binding of the this keyword. And you know what I'm going to do is I want to use the last hour for prototypes. And so I think we're going to jump right into the prototypes lesson after this. So let's take a 5-minute break. Actually, first, let me answer any questions we have. I don't want to get this too big, and then we'll go to a break. Would a good way of thinking about this be? So, okay, let's see. Let me read this again. What a good way of thinking about this be? So say that it allows the function to access information from the parent scope. I would say a better way in thinking about it is you decide which scope. Like, that's the craziest thing. Is like you are telling which scope to be used. So it's not just parent scope, it's the scope you decide. Okay, how come hobbit.food doesn't work instead of this.food? Hobbit.food does work, by the way. It's just limited to just Hobbit. And what if we had other food that wasn't just Hobbit? So don't worry about that. It's not reusable. That's why we didn't talk about it. So what about cook method inside of an object? How is that different? So this is different because, remember, it's a method, as we know, and it's got its binding assigned to where it was invoked. So if we come back over here, the reason we're not using .call, for example, is because it knows it's inside of an object and behaves differently. So Hobbit is an object, literal, versus introduction is a function. Two different pieces. Okay. We looked at bind. Yes. In your case of passing an object in, wouldn't you have to use the same name? Wouldn't you have to use name? No, because I'm referencing person. So if I come over here, in this example, I'm referencing person up here. So it's going to be person.name, and then that's Ruby, right? Because this dot is actually person, because why? We passed in person. JSON notation. So Google that one, but it stands for JavaScript Object Notation, and it's a certain way of writing object literals that all developers can agree on, even though we all have different opinions. So go read that. Functions are not objects. Okay, wait. So functions are not objects. They actually are objects, but they inherit methods like call from the function object. Yes. So functions are objects. We're going to talk about that after our break. Can apply be used to call object properties? Yeah. Or let's see. Are you thinking about object literals? No, we don't have to do that because of the implicit binding of this keyword. So again, we don't have to use call and apply in this scenario of here, because it's implicitly bound by the nature of the object. So we don't have to say .cook, .call, right? And then this, and then args. Like, we don't have to do that because it's already implied automatically by being hooked into the object. So that's why we started with implicit binding. We already know what tree we're on, right? We don't have to like guess. Do you recommend videos more or text? Both. I like both, but for today, I really like that Tyler McGinnis video and the content that we have as well. Can we swiftly recap bind? I'm not understanding how to call the variable for it run properly. Sure. So if we come back over here, bind, notice what's happening here. The only difference between these two, let's just look at them all like on right now. So notice that call and apply are just being called instantly on the method, instantly called on the function. But notice the syntax difference here. We're putting a const, we're setting up a const. These two do not have that set up, okay? So that's the difference. These two are not being used for later. They're not being stored in memory. They're executing. Over here, we're using it for later. We're storing it in a value. We can call it whenever we want, whenever we need to use it. This will make more sense next week. Right now, it's just like, you got to trust me that bind is really helpful. Okay. Would arrow function work without this keyword in the method? No. We talked about that one. Maybe these are older questions. Oh yeah, these are older questions. Okay, let's go ahead and take 5 minutes. When we come back, we're going to get into the new keyword binding and see how that works to make new objects. So here we go, 5-minute break. All right. Seeing some good conversations coming from questions. I guess I just didn't answer at the last second there. Regarding the binding and the non-binding of an arrow function. So let's go to MDN arrow functions. So in this case, an arrow function expression is syntactically compact alternative to a regular function expression. Although, without its own bindings to the this, argument super, or new target keywords, arrow function expressions are ill-suited as methods, and they cannot be used as constructors. So I can't really be more clear than that. There is no lexical binding. It's literally, there is no binding. And so if there is no binding, what happens? It tries to go to the next place that binding does occur, whether that be window or another containing object. So if you've seen that found in React, it's usually because it's pointing back to another containing class that's got its own binding already set. So just be very clear, there is no lexical binding of this. It's an unbinding. There is no binding. Sweet. Okay. Great stuff. Great thoughts. If you didn't understand a word I said, you're in a great spot too. Don't worry about that. Moses definitely has more experience here to even ask that question. And I'm not concerned. Like, I think that's a great question. And you shouldn't be concerned either. All right. So here we go. You are in a great spot, Emmett. You're trying. We're trying these things out. Okay, here we go. JS3 guided project prototypes. This is a new code pen. I want to keep it separate because we're going to be talking about the new binding here. All right, so I'm going to come back to my JavaScript. And one of the things that we can do in JavaScript is create objects. Remember how we made the Hobbit object and it wasn't really reusable? It was kind of static, had one ability. What if we had 50,000 objects of information coming in from us from like a medical records company or something? Like you went to the hospital and they're trying to create a new user inside of their system. That's when things get real. It's like, wow, it's more than just one or two hobbits, it's 50,000 hobbits. So in this case, we have to be able to create 50,000 hobbits with different abilities. And so that's when it's like, oh my gosh, how do we do that? Well, we can actually build a thing called a constructor function. And a constructor function can construct other objects. Like that's its whole purpose. And so let's talk about what that even looks like. So I'm going to be using the Flintstones. We used them from the training kit. I think it's just easy to understand them. So let's say I wanted to make Fred Flintstone. And let's say I made him into an object here. And I gave him an age, 35. I mean, if we went, we could go billions of years, but 35. Name, Fred. Location, oh my gosh, can't spell today or any day. Bedrock. And then he's got a phrase he always says, right? Yabba dabba doo. Yabba dabba doo. All right. So we've got a Fred object. So in this case, if I wanted to copy and paste Fred, and we could bring Wilma in and Pebbles and the whole crew. And so we came in here, we said Wilma. I think Wilma gets mad at Fred. I think she's Fred? Or whatever. So in this case, we've got Fred and Wilma, and they're both basically identical, right? The thing is, like, I had to make a new const, right? Just like with hobbits. So if I was doing the hobbits before, it'd be Sam and Frodo, and then I'd have to make this information again. The problem with this is if I wanted Fred and Wilma to be able to do something, for example, what if I wanted them to speak? So I come in here and I set up a function, a method, right? And so they both have the ability to speak. Well, the thing is, like, I have to share this. Each one of these objects has to instantiate this method individually, like every time. And if I made 50,000 more Flintstones, I'd have the same problem where they have all these things that are in common, but they don't share anything. It's not very dry. I'm repeating myself quite a bit. So the problem is abstracting these things out and creating new objects given a chunk of data. So, for example, you fill out a form at your hospital and you give them your name, your birth date, your whatever you have to put in there. Then they take that information and they store it in a database. They then have to take that database full of information and turn those things into objects so that they can assign things and assign methods to you and build out a huge application tracking. So in this case with Fred and Wilma, we can't repeat anything. We have to copy and paste everything. It sucks. Now here's the thing. Some things are unavoidably copy and pasted. Being 35, and let's make Wilma 37, older and wiser. So in this case, 35 and 37, those are unique. The name, Fred, is unique. Bedrock, sure, it's the same, but it could be unique. And of course, their phrases are unique. So in this case, the right side values are completely unique, and we can't like recreate them. But we can recreate the left side. So age, name, location, phrase, for as many Flintstones as we need. So there is a portion of this that could be repeated and saved in memory and used over and over. And then the right side is just unique. Well, we've just got to receive that information. So let's talk about how we can construct 50,000 Flintstones. So here's how it starts. It's with a thing called a constructor function, like I was saying. It looks like this, function. And I'm going to use parent. We'll use a parent-child relationship. We'll bring pebbles in here so it'll all make sense. I want you to notice something else. I capitalized the P here. Naming convention does not matter, technically speaking, but what it's doing here is it's letting the next developer know, hey, just so you know, I'm making a constructor function. This is going to be making lots of objects. So this lets people know, like the next developer, that this is a constructor function, just by its very name. That's why we do it. Okay, so in this case, I want to pass in age, name, location, and phrase over and over to parent and create a new object from it. The problem is, how do I pass those things in? I have to be able to call parent. So this introduces the new keyword. This is something we haven't talked about yet. So here's what it looks like. I'll keep this here originally and I'll rewrite the new version of how we could do this. So instead of assigning it directly to an object, I'm actually going to say new, like quite literally type the word new. And then I'm going to reference my parent constructor like this. Like that would be the line that I'm writing. But now all I got to do is pop my object inside there. So new parent. And then I'll pop my object in. Of course, I got to have that open curly. Oops. So what I've done here is I've said I want to make a new constructed parent. I want to make a new version of Fred. So this thing is just static Fred. It's not doing any good. We don't need it. In this case, we're now going to make a new version of Fred that has new abilities, namely methods, and can share properties with other objects. So we're going to do the same thing with Wilma. So I'm going to come in here, new keyword, parent, open and close parenthesis. Whoop. Man, autocompleter's messing with me. Like this. So now what we're going to do is we're going to invoke parent by using the new keyword. So the new keyword automatically assigns a this binding. By using the new keyword, we gain a this. So I've got to pass in some kind of something. So in this case, it's going to be my attributes, right? Age, name, location. So let's see what happened. I'm going to say console.log attributes. Let's just see what actually occurred here. So you can see I've got Fred and Wilma are being brought into the same function. Okay. Let me hit settings, get that run button back in. Did I give you this link yet? I think I did. Yeah, I did. Okay. So now we've got something interesting. We've got the objects coming in. So let's see what's going on with console.log this. What is the this keyword bound to? Now, before I run this, do you think it's going to go to the window? Or where will it go? What do you think is going to happen here in this console log? Don't run the code. Just think with me. Okay, so I'm seeing object and I'm seeing parent. Let's see. Save and run. Object. So what the heck is going on here? It's an empty object, by the way. Yes, so Gregory says parent because of the new keyword, but really what is parent doing? What does a constructor function do? What is its whole purpose in life? It's to create objects, right? So what did it do? It created these two objects that have nothing inside of them. It did its job. Okay, so how in the crap do we get stuff to go inside these objects? Well, because we have access to the this keyword, we now know that this is basically our blank object. So we could say this dot age, right? Let's call it something new. Let's say new age. So we know that it came from the new keyword. And we can assign it the value of the age that was received. So we received attributes, right? And we could say dot age like that. So now let's run this code and see the difference. Run. Huh, nothing changed here because I didn't console log after that. Okay, save and run. Now we're starting to build a new object. You see what we're doing? So new age was created from the old age into a new object. So over here we have the old values. These are the values that were inputted by the user. The new age is the new values that we received for our new objects. This will, bear with me, Emmett, we'll get there. Because right now what we've done is we're creating a new object. We're creating a new object. All right, let's go down the line and create the rest of our object. So we'll say a new name. We'll say a new location. And we'll get a new phrase because they're going to be new in our new object, right? They're coming from an old thing and becoming new. So these are the things that are coming in, right, from our attributes. So they're all coming in here. So if I were to draw a line here, it would go from here to here. And then all that information is here. So all this stuff turned into this. But remember, a constructor function's job is to build new objects. And so if we want a new portion, we've got to set up the new stuff over here. That's why we set new. All from the new keyword here. Okay, so let's see what our new objects look like now that we've got them in place. So I'll clear this, save it, and run it. And look at this. We now have two fancy brand new objects. I know they're new because we used the name here to signify that they're new. So at this point, you're probably going, you repeated yourself twice, and good job, Josh. And you're not wrong. But here's where it gets interesting. I could actually use this new object to share methods. Okay, that's kind of cool. So if I come in here and I say speak function, and I can return something or console log it. We'll console log just to keep things simple right now. Well, we'll use return like we've always been. We've been good. So let's say return, and we'll say, so what could we say? We would say Fred says yabba dabba do, right? But we don't want to hard code it because there's also Wilma, and there's Pebbles, and there's somebody else, and Dino, and all these other ones, right? So If we come over here, we want to change this out to be this dot new name, right? Because it's constructed. So of course we've got to interpolate it. So we'll bring in our string interpolation. So this dot new name is Fred says yabba dabba doo, right? Of course, Wilma can say Fred. So we come over here, new phrase, like that. Okay, so now if we come down here, this is the view. So if I hit save and run, let's see the difference now. Clear and run. So something happened here. So this dot speak, assign the value of return, this dot new name says this dot new phrase. Let's see if there's something I goofed up on here. I guess there's, oh yeah, I totally just don't have a console log. I must have deleted it on my way to the function. So let's see what our new objects look like. So if we open them up, this is where things just got interesting. So Fred and Wilma do not have the method speak on them. Are you seeing this? Our light bulb's going off. There's no method here. And now because we made them into new objects, guess what? They both have a speak function now, speak method. Isn't that cool? So instead of having to write that function 400 or 50,000 times, no joke, we now wrote it one time and it applied 50,000. That's pretty freaking cool. Because now methods do something, right? They perform actions. And we're using all of our properties up here. So now you can see why, whoa, this is pretty cool. Like I could see now how we make 50,000 new Flintstones and they all gain the speak method for free. Like we didn't have to write it 50,000 times. So that's where constructor functions are really powerful. They allow us to repeat things and share things across objects. Otherwise, I'd have to go in here and write this down every time. So in this case, I now gain all these functions. So here's the problem. Here's a problem with having a function inside a constructor. When a constructor is made, a new object is made, if the method is built into the constructor, it has to ping it every time that invocation occurs. It's memory intensive. So if I want to take it out of the constructor, I have to introduce you to a new concept, which is called prototype. So what I mean by that is if I want speak to be taken out of here, but still be usable on all these, I actually have to bring it out of the constructor function. I don't want to see all my methods inside my constructor. This is really costly to the browser. So I need to abstract them out. So how we can do that is we can reference parent. So we can say parent, because it's up here. And then we can say dot prototype. All right, so this is the new thing today. But the biggest thing is in this right now, it's out of this keyword. So with prototype, we're basically saying, I want to add speak on all of our objects, but I'm not going to put it in the constructor function. So let's see the difference now. Hit save and run. Oh man, I always forget the console log. Oh, why do I do that? Okay. Save and run. So see how this is a little bit unique. We come in here, we have our function, but notice that it's a little bit different. It looks a little bit weirder here because this was added secondarily. So it's part of the thing, but now it's on the prototype. Okay, what the freak is the prototype? Well, let's go look at it. MDN prototype. Prototypes are literally the mechanism by which JavaScript objects inherit features from one another. And so it's going to talk about what JavaScript is. I'm not going to read all this stuff, but I do want you to understand, like if you want to go deep dive on this, highly recommend it. It's very important. So prototype is how we can actually pass these things across thousands of objects, just like we did before with our constructor, but now we can actually store it for later. So prototype, I want you to think about it as kind of the DNA of Fred and Wilma. We can actually go into their DNA and splice in new methods. So Fred and Wilma have their own abilities. We can actually give them superhuman abilities, new methods. So let me show you. We're going to go to the console here. I'm going to say console, maybe, type here, console.dir. And I'm actually going to show you what an array looks like from a directory level. So if you look at this array, let me get my highlighting tool here. I want you to notice something. We've got a prototype here. And notice it even has a thing called a constructor, which we've been using, right? So this prototype makes up all the methods that an array can use. Notice that we've got the properties up here. So here's .length, right? We even have a name. But in this case, all of the properties that you were using all week are innately built into every array. So if I open this up, we should see all of the property. There are all the methods. Isn't that cool? Map, filter, reduce, they're all here. They're all built into arrays forever, as far as like the latest standards of ECMAScript go. So in this case, all the array methods that you were using, they're all part of like anytime you make an array. So, okay, what does that mean? Const, let's just make a new variable. Let's just say myvar or my const, assign the value of, oops, testing. So I've got my const. Okay, I'm going to say console.dir. I'm going to say my const. Doesn't show much, right? It just says testing. It's not showing like this isn't an object in here. It's just a string literal, right? Now, what if I made a new object? Const, my obj, assign the value of, open and close curlies, name, I said, web19. Console.dir, my obj. Look at this. I open it up, and you can see I've got a name key value pair, and then I've got something weird that we haven't talked about before called a dunder proto. What a weird name. Well, it's actually pretty sensical. It stands for double underscore proto because the syntax has two double underscores in the front and back. So dunder proto. What the crap? So what does this do? Well, this shows us where we came from. Whoa, that's kind of deep in JavaScript terms. So this dunder proto talks about an inheritance chain. So dunder proto is pointing back to where we inherited all our stuff from. So it's actually object, right? That's pretty crazy to think about. So if we go back up to array, and we look at arrays dunder proto, what is that? That's the function. Wait a second. Are you telling me that arrays are actually fancy functions? Yes, I am. Because if you open up the dunder proto, guess what? We have access to apply, bind, and call on every array, if needs be. And then look where the arrays came from. Look at the next dunder proto. It's object, and it goes back to the original object. So when we say everything in JavaScript, pretty much everything in JavaScript, is an object, we are literally inheriting through prototype chains here, dunder proto specifically, these things. So let me show you another way. So let's say we've got this kind of inheritance chain that I'm going to build here. And we've got an arrow showing inheritance going down here. So up here, let's say that this is our object. Then we come down here, and this is our function. Then we come down here, and this is our array. So in this case, each one of these arrows is prototype. Is dunder proto, I should say. Gosh. So every time you see one of those red arrows, well, let me grab it again. That's annoying. These represent the inheritance chain that's getting passed down. But everything that these things can do by themselves, so object, function, array, all those methods that exist on there, that's the prototype. So prototype is what it can do by itself. Dunder proto is where it came from. So think about yourself. Think about your own skills and your own abilities. You can do things that your parents cannot do, right? Like I can program, my father cannot, for example. So, but I inherited skills that my father can do. And so, but he can't automatically become a programmer because I learned programming. It's the same concept here. Object has innate methods that it can use and properties. Function does too, and array does too. But as we inherit them down, guess what? Arrays can take everything functions can do and everything objects can do. So this is called prototypal inheritance. All right. So let's talk about where things got crazy. I see a lot of people with sad faces. When did we start to get lost? When we said the word prototype? When was the first thing? Monday. Oh, Tyler. So prototype. Okay, so Mackenzie, can you put in words what was confusing about prototype? Can you put in words like, this specific thing was really, really, really weird? Okay, Amanda says, when you said arrays are fancy functions. Okay, let's talk about that. So in this case, when I'm looking at arrays, I'm saying, where did they come from? They had to come from somewhere. And dunder proto is where it's coming from. It's pointing to its inheritance, pointing to its parent, Amanda. And so array is pointing to function, like the base function. So if I open this up, you can see, if I go over to my function here, remember in MDN, all these functions, properties and methods. So arguments, callers, length, all that stuff, and then apply, bind, and call, the stuff we talked about. So in this case, if we come back to this, you can see they're all here. So arrays are derived from functions. Oh, sweet. Okay, you get it. Awesome. All right. Mackenzie says, I don't understand how prototypes can be inherited and be something new. I think that's a great, thank you for putting that in words. Okay. So in this case, when we're making something new, we're saying, I want you to be of a certain type. So object, for example. So if we go back to MDN object, like just the object itself, we gain all of these properties and methods. Okay. Whether you know to use them or not, we gain them. Like they're always there. So I want you to think of a prototype as like, what is a prototype in the physical world? Usually when you think about a prototype car, it's the first of its kind, right? It's like the first iteration. And then we have new models that are based off of the prototype. So that, I think that conceptually, Mackenzie, is how I would answer your question, is we've got a new version of the original car with all of its bells and whistles. Okay. Eric says, I don't get how to use the whole window console thing in Chrome. So are you talking about the dev tools, Eric? Just like hitting the inspect and then like getting into it here? So with window, we'll get into that more next week. That's going to be the document object model. So we were just talking about console.log this, right? And you're saying that's where things got a little weird. Okay. So window, by the way, is the browser we're living in. Like everything you can see here, all the light, the land touches, this is window right here. So that's it. There is no like further explanation as far as like what the window is. It's quite literally everything we see here. But now that we know a little bit more about properties and methods, you can see how crazy the window is, right? It's got a lot of stuff on it. So every time we make a new web page, or every time we open up a browser, this is actually JavaScript. Like these are DOM objects being created by the browser. It's pretty crazy. So we'll talk more about that next week with DOM manipulation. That's why I'm saying don't like stress about window right now. But pretty cool. Pretty cool to see that you can literally change anything on this window with the right code. So that's it, Eric. You don't need to go any deeper than that. It's just that's the window. Okay. So Tyler says, why wasn't this .new name wasn't replaced with Fred? I said wasn't twice. Brain broke. Don't worry, my brain breaks too when I'm coding. So if we go look at Fred over here, Tyler's saying, why wasn't this .new name replaced with Fred? And it was replaced with Fred right there, like right there. So I guess it was replaced. So remember, over here with new parent, these are objects that have not been created new yet. These are just like the hard-coded values. This is just as if somebody. Okay. Seems like you're getting it now. Yeah, Eric, that's a great way. Eric says something I think is worth repeating. He says, I feel like I'm trying to understand too much instead of just taking it face value. That's really well put. I want everybody to feel that, think about that. Like, don't try to understand every little thing under the hood at this point. It'll continue to reveal itself. So just at face value, what are we doing? We're taking a new parent, or we're taking Fred and Wilma, and we're making a new version of them. Okay. By the way, that's why we have training kit. We have videos to go watch the specific thing that you're struggling with. So if we were getting our butts kicked by this keyword, go watch this video. If we want to watch all this stuff and somebody else explaining it, go watch this video. But do it after we take the break, okay, after we get to lunch. This stuff's tough. It's hard, but it's not unobtainable. One step at a time. So let's kind of walk through this again. So if we come over here, we've got Fred, and Fred is got an age, name, location, and phrase. We also have Wilma. They are both unique, right? They have different ages, different names, different phrases. And they could have different locations. They just happen to both live in Bedrock. So I want you to think about this times 50,000. Like, I'm not going to write 50,000 objects, but I want you to understand that like this could be multiplied by 50,000 residents in Bedrock. And they might have to all come in and get new objects made for some app we're building. So in this case, they get pumped into our new beginning constructor here. And then we have our age that's coming directly. So if I get rid of all these lines, just go one line by line here. Age comes in, goes into attributes, and comes over here. So age stops here. But notice that we set up this .new age to create the new object. So all these things are going off to make a new object that we put out here in the console. So we had to get these things somewhere, right? So 35, Fred, Bedrock, yabba dabba do. They all had to come in here one by one, right? Because we brought them in through our object up here, through attributes. So this is all connected here, one to one. We then make a new object over here based on these pieces And the reason why new objects are even valuable is because we can share methods across them. So in this case, we now have the ability to speak, and we held it in a thing called prototype. Prototype allows us to share methods across all of these objects. So in this case, speak can now be shared across Wilma and Fred. So if I come down here, and I say console.log, Fred.speak, hit save and run, you can see Fred says yabba dabba do, right? If we come down here and we say Wilma.speak, save and run. Or let me get rid of all the, let me get rid of this console log that we needed for so long. Save and run. So in this case, Fred says yabba dabba do, Wilma says Fred. This right here is amazing because now we could share this method. We only had to write it one time versus having to write it a bunch of times inside of here, right? Minus the parent, yeah. So it would look like this. That would be awful to have to write speak in every single thing. Instead, we only have to write it one time and everything shares it. Nice, Tyler. Tyler says, hey, I get it. Sometimes it just takes multiple iterations. So in this case, we could add another method if we wanted to. Like we could come over here and just say, location or, where they're from. And so we could say this dot name is from, and then we could just say location, right? So we come over here, save. We'd have to come down here and say console log, Wilma, location. So save and run. And then it says Wilma's from Bedrock. Do you see how this is so extensible? Like we can take things, just go bonkers with this. And it can be used across thousands of objects. So I could throw Fred in here and all I got to do is just swap in a different object and away we go. So we come in here, Fred is from Bedrock, Wilma's from Bedrock. And of course, if we change this, so Stone Town, I don't know, save and run, we can see at least the difference between the two. So Fred is from Bedrock, Wilma's from Stone Town. So methods allow us to share across. So the last thing we need to talk about is inheritance to other objects. So for example, if we bring Pebbles in here, so Pebbles gets created. The problem is Pebbles is not a parent. Pebbles is a child. So we have to make a new constructor function just for Pebbles. Pebbles is not 37. Come in here and say 2. The thing is, Pebbles has something that the parents don't have. Pebbles has a toy. She's got a rock doll. And so neither Fred nor Wilma have access to toy. Only child has it. This is very common in programming where one thing in a program needs to do one separate thing. So here's the problem with object-oriented programming is if you look at Pebbles, she also has age, name, location, phrase. She has all the things parent has, right? So if I were to make a new constructor, function child, and let's just make it different by saying child attributes, just so we can see that there's a difference. And so what are my child attributes? Well, it's all these things. They all get brought in. So if I were to come over here and say console.log child attributes, save it and run it. In this case, you can now see we have age 2. Oh, I got to change the name from Wilma to Pebbles. And we'll say Bedrock. And she will say Mama. Okay. So in this case, we can now see we've got pebbles from bedrock. Okay, all the stuff's coming through. But remember, this is not the new object. This is just the current hard-coded stuff. At this point, can Pebbles speak? No, she can't speak. She doesn't have access to anything. So if I come down here, and I'll say, you know, child, and then over here we'll say parent, so we can see the difference between the two. If I tried to say pebbles.speak, if you think about what's going on here, you're like, wait, yeah, Pebbles cannot speak. There's no way. There's nothing down here. So if I comment all this stuff out, you would see that nothing runs. There's an error. So if I inspect this, look at the console. Pebbles speak is not a function. Well, yeah, it is. It's up here. It's a method, right? Well, the problem is child is unaware completely of parent. And so if we want to make child aware of parent, we've got to do a couple things. So first off, we don't need to, I mean, we could write this. We could rewrite this whole thing, by the way. But now we're repeating something that doesn't need to happen, right? Like this stuff already existed. So guess what? We can use something we just learned how to do. We can use our explicit binding because it's a function, right? So I could say parent.call, right? And I can throw in this keyword. I can throw in all the new things that we're going to be bringing in. And then I can say, pass in all the attributes of child attributes. Pass in all this stuff. So that can link the constructor together. That's pretty cool. So I'm taking all this stuff here, age, location, name, phrase, and I'm bumping it up here so it can be made into a new object. So that's pretty freaking cool. Remember the analogy of telling where the tree to grow? I'm forcing parent to do all this stuff for me so I don't have to redo it. So that means, and of course I need to bring in this dot toy because it's new, right? So this dot toy is assigned to, so new toy to keep our naming convention together is assigned to child attributes dot toy, just like we did with everything else up here, right? Phrase, location, name. The only thing is child has a unique thing that parent doesn't have, which is a toy. Okay, so if that's the case, Pebbles should now at least be able to have an age. So if we hit save and run, undefined. So we have to go look at what's going on here and say, how is this undefined? So Pebbles, new child, we come up here, we have a function child, it receives child attributes. Parent.call, and we pass into this keyword that belonged to child from our new keyword binding. Child attributes gets passed in this dot new toy, child attributes toy. So in this case, oh, I forgot, it's new age. Because age is the old age, so it's our new age. So if I hit run, we should see 2. There it is. So that's pretty cool. So child inherited all of the properties from parent via our explicit binding of this keyword. So the problem now is, can Pebbles speak? Because it's on the prototype, it's not there anymore. Can Pebbles speak? What do you think? No, she's 2. She can still say mama. I got a 2-year-old. So if we hit save, clear, and run, let's see what happens. Nothing. It's the same error. Function doesn't exist. So here's the craziest thing, I think, of all the things we're going to talk about. And you're going, oh boy. But the reality is, there's no reference to the prototype. The prototype is not aware down here. So to link the prototype together, we have to use a thing called object.create. Let's see, where is it? I thought I had it already. There it is. So the object.create method creates a new object using an existing object as the prototype of the newly created object. Think about that for a second. We're going to be using an existing prototype. So if we look back here, what is the existing prototype? Well, it's got speak and location on it. So we can use object.create on the next line here. So if I come over here, I've got my child, right? So I'm going to say child, well, your prototype, where you store methods, right, is going to be reassigned to the new method that we just saw, object.create. But how does it know where to get that prototype from, right? Because object.create creates a new object using an existing object as the prototype. So I've got to have an original prototype. Well, we have one, right? It's parent. It's already set up. So we can say parent dot prototype, because this will link all the methods together. So child prototype, we're going to grab all the prototypes here and bring them into a new version of child. We shouldn't be like freaked out by new stuff, because we've been making new stuff this whole time, right? New age, new name, new location, new phrase. And this is just a new prototype. So now that we've linked them together, Pebbles now has access to speak. So let's see if it worked. Can Pebbles speak? Uh-oh, something's not set up right. So in this case, oh, looks like I've got an extra. Dang it, autocomplete. That was not a trick question. I was like, what's going on there? We should see sub. There we go. Pebbles says mama. Perfect. So now Pebbles has all the things lined up. So in this case, this sets up the Dunder proto to inherit the prototype from parent. So remember, prototype is where we store methods. Dunder proto points to where its parent should go to. So in this case, we now gained a Dunder proto for Pebbles that pointed back to parent. I'm fully expecting you to come back and watch this portion of the video if you're confused right now. That's why I'm speaking slowly and clearly. Because once you've seen this a couple times in your assignment today, come back and watch this. And you'll go, oh, okay. For now, I get it if you're like internally freaking out. I really do. So the next thing, last thing, is Pebbles has got to do something on her own, right? Like we've got to prove that she can do something. So we'll say child.prototype, prototype, and we'll make a new method called play that only Pebbles can do, or any child, I should say. So in this case, we could then say return, and we'll just borrow something up here that only Pebbles can do. So this dot new name, because we want to say Pebbles, plays with, and then this dot new toy. Only Pebbles can play with a toy. Fred and Wilma don't have that ability. So I can come down here, hit save. Pebbles.play and run. And Pebbles plays with the rock doll. But if we try to get Fred or Wilma to try to play, let's see what happens. We get an error. Go to console log and it says Fred play is not a function. Because parent is unaware, on purpose by the way, we don't want parent to be using child's methods. The whole reason child exists is because they have some unique feature that parent doesn't have. And this is as crazy as it gets, by the way. This is the end of the crazy tunnel. Everything is just repeating this pattern over and over again. This is called pseudo-classical prototypal inheritance. I know it's a mouthful, but this will make sense tomorrow when we do the Flexbox. So today is inline block with this stuff. Tomorrow we'll introduce Flexbox with class and syntax. But for now, I need you to understand the value of this is recreating n amount of objects, forever, giving them the ability to share methods between themselves. And this is really the beginning of object-oriented programming and inheritance-based applications. So right now, you can probably see that child is inheriting all these things. Well, what if Pebbles didn't need location, but only needed speak? That is the inherent problem of object-oriented programming. Because it's like, you just wanted to get the one thing, and you have to take everything. And it's really intensive on programming. So the famous quote is, you wanted a banana, but you got a banana being held by a gorilla in the whole jungle. And that's the problem with inheritance patterns like this. It's like, what if Pebbles only needed to speak? Well, tough luck. Pebble also has the ability for location, which does convolute things and make things heavier. So that's where a more functional composition-based programming pattern is going to be way better. But we'll talk more about that when we get to React. Okay, that is what we've got for today. I'll go ahead and hit up the questions for anybody that wants to stay. Otherwise, you can take off for lunch. Your project is going to be building a game, following these instructions. So follow the README file, and you'll notice in the assignments, I've got everything's commented out. So you just got to follow the comments, read the instructions, and by the end of the day, you should be able to get these things to console log out properly. And then stretch task is going to be awesome today if you can get to it. So basically, you're going to make your objects kind of fight each other, like a mini video game. If you can get there, which I think you can. Just give it time. Take a break, come back, line by line. Okay, let me hit up the questions thread here. Let's see. We've got plenty of questions. Again, you're free to go. I'm just staying here extra for anybody that wants it. So where does JS store the code once it's compiled in the browser? So you can see it in the sources tab. So like when you inspect, you can see what's going on here. You can see where the code is stored, if there is any JavaScript being used in this page. And it'll just keep it there. But as far as like where it's stored, it's usually stored in cache and memory on your computer. So this one's got a lot of stuff going on. Took a while. So you can see all this stuff being used. And so memory, random access memory, RAM on your computer is using a lot of this stuff. And so if you've got your browser open, a bunch of tabs running, you can really chug your computer if there's a lot of JavaScript going on, a lot of compilations going on. I want to be clear, the amount of JavaScript doesn't matter. Like you could have 1 billion lines of JavaScript, and if they were super succinct and did one thing, it'd be fine, versus one bad loop could just wreck a whole app. So JavaScript size does not matter, compilation and speed does. And so that's why we spend so much time with that. In computer science, later on in your time here at Lambda School, is the computer science portion. We'll talk about big O notation and how to get the time complexity of functions, for example. But that's months away, so don't freak out. But that's where we're going. Okay, doesn't the number of args have to match the params anyways? What if the spread operator doesn't match the number of params? So usually you're just spreading off into forever and not worrying about it. So the position does matter. It just depends on how many arguments you need. I would actually recommend you go play with that. Go try that out. Okay, in general, we should be trying to build our code for scale, yes? Yeah, of course, in general, but in reality, like when you're building something, sometimes you don't even have the grand scope of what it will become later. So I think sometimes paralysis by analysis happens way too much in programming. And you start thinking and building for a 10,000 line app when really you just need 100, and just I don't know, that's so tough. That really is a question that could be answered with design patterns in JavaScript. I would recommend you Google design patterns in JavaScript, and that's going to be a great way to start thinking about those things in the future. Can you use object literal shorthand in constructor functions? Object literal shorthand. Guess I'm confused by that. Object literal shorthand. If you're talking about string template literals, yes, you can. But with constructor functions, we have to use that new keyword and pass in, something so it can be consumed. Why would you want to put a function in the prototype instead of the constructor? What's the difference? So that's a great question, and the answer is memory. So if we can avoid having methods inside of our constructor, then it's not going to call every time we do anything. So if you called an array every time you had an array, so imagine here, where are we? Where's our arrays? I thought I had them up. MDN array. So the reason that we even have a prototype to store our methods on is because when you call an array, like when you create an array, all you're getting is this stuff right here until you actually invoke the method. So it's stored in memory one time instead of 400 times, for example, if you had 400 arrays. So that's the beauty of prototype, is that let's say you did have 400 arrays. If you had all the methods in each constructor, you would have 400 unique instances of every method. Let that wash over your brain for a second. You would have 400 instances of reduce, filter, map, right? And so, and by putting it on the prototype and inheriting it down, you only have one instance of map, one instance of reduce, and it's just invoked 400 times. So it's an architecture thing, saving a lot of memory. Okay, great question. I think it might be helpful to understand some of the computer science that leads to JS capabilities. Can you recommend a source for overview? I think the reason we introduced, well, I know the reason we introduced JavaScript first is because we need to give you concepts that you can even understand computer science with. So, for example, when you get into computer science, we talked about like big O notation and algorithms and data structures. Well, if you don't even know what a data structure is, how can you even grapple with it? And so we're trying to introduce you to the fundamentals. That's why it's literally called web fundamentals, so that when you get these things, you can actually understand them later. If we started with computer science, I think a lot more of you would drop off. And if we ended with JavaScript. So that's why we start with JavaScript, HTML, CSS. We've got to get these small wins so that when you do get to the bigger conceptual things, you're ready to go. And man, that's really what separates Lambda School, is our computer science program. It just leaps and bounds. Like, there's other code camps out there that are great. They do the same thing we do as far as like giving you introductions to a framework and concepts. But what really sets us apart is the pragmatic thinking and the critical thinking in computer science. That's just, I mean, people would probably be here just for the computer science program. That's how important it is. So yeah, patience. Focus on the JavaScript right now. Only the attributes get passed to the parent and not the methods. That's right. So in this case, the attributes are getting passed in. We didn't create any methods to be brought into the constructor. How would you not get the whole jungle if not inheritance? So what you can do is you can write certain functions in ways we're not going to go over because we're already way over time. But look up compositional programming patterns. There's some awesome Medium articles from Eric Elliott, for example, is one of my favorites. And they give examples of how that looks. Okay, and these are the questions Moses asked. I think I answered them with the non-binding of this keyword. So I think we're good there. Could you use args, spread args as a parameter in introduction? Yeah, so yeah, we did do that actually. So okay, now we're getting into this keyword stuff, kind of mixed in. How do you know when property should be inside of instead of outside of after that? Inside of the invocation instead of after the invocation? Context-wise, I'm a little lost there. How do you know when the property should be inside of it? If I'm looking at this here, this is being passed in, it's receiving all of this object, right? So if that's where you're asking, like inside these parentheses, the reason I'm putting it, so if we were to delete the object literal, this is simply put a method call, right? It's just a function called a parent. but I'm passing in an object literal and receiving all of those so I can dot syntax into them. So that's how I know I wanted to put it inside of the parentheses, because I wanted to pass in a big chunk of information. So hopefully that helps. Sorry if it didn't. Quick refresh, if you could. How is attributes assign the value to Fred and Wilma? Is it because new attributes link them together? So if we come over here, so if we say Fred and Wilma both have these specific attributes, remember, by the way, I'm making an assumption here that we'll always have the same data. And usually that assumption can be false given, you know, crazy people typing in crazy stuff to their forms. But if we were living in Bedrock where there was magical Bedrock, you know, iPads in a waiting room or something, and they were typing in their information, the fields, the input fields would be age, name, location, and phrase. Does that hopefully help frame it for you? So it's like you've got a form, they can only put in 4 values, and that's why I know I'm only going to have 4. But what I do on my end, on my app end, is I give more abilities, but I have all this information that I'm expecting to receive. So hopefully that helps. Bedrock iPads. Are prototypes binding to the parent object or whatever we're pointing to? Yes. So if we were to go look at the underbelly in the actual console here, and we got rid of Fred.play because it's going to throw an error, because remember, he can't play with a toy. So clear this out so we're basically error free. Okay. So if I were to say console.dir to get the directory of pebbles, looks like it doesn't have it in this memory, so I'll just grab it really quick and throw it in. Hit enter. Get pebbles. So now you can see, if I open up pebbles, first off, look what kind of object it is. It's a child. If we open it up, look where pebbles is pointing to. That's pretty cool, right? If I didn't do object.create, that would not be pointing to parent. Let me repeat that. If I didn't do this line right here, right there, that would not be pointing to parent. It'd be pointing to object. And it wouldn't know how to get those methods. So for example, if I were to delete this line, this would not say Dunder Proto. So let's go to a new browser window here, inspect, console, paste, and this time I'm going to delete this line. And I'm going to get rid of this line so I don't get any errors. Okay, so I'm going to hit enter. And now I'm going to do the same thing. Console.dir pebbles. Open up pebbles. Look at that. See how the Dunder Proto is pointing to object? Whereas when I was in here, it's pointing to parent. So that is exactly what object.create is doing. It's setting up the inheritance chain. It's saying, you're my parent. I'm pointing to you. So it's almost as if you can choose your own parent. I mean, that's what it's doing here. It's showing where it needs to inherit from. Great question. So by creating the person prototype speak, we add that particular function to all persons. Why would we do this and not put that function inside a person? Because we don't want to write person, we don't want to write speak 50,000 times inside the constructor for memory, right? We don't want to do this, and we don't want to do this. Both of those are bad experiences for the memory on our computer, and of course for writing these things out as a developer. So by putting it on the prototype, we only reference it one time for 50,000 use cases. That's the power of prototype. When console logging this for the parent object, it lists out each object as object attributes and not the variable name. Great observation. The reason for that is it's creating new objects, right? So if we come over here and we say console log this, and we hit run, we can see, so what you were saying was, hey, look, there's the object. Why doesn't it say Fred? Or why doesn't it say Wilma? Well, remember, constructor functions build new objects, and they don't have a name. And so in this case, we can look at the properties, though, and find out what their name is, right? So in this case, we can see it's Pebbles, it's Wilma, and it's Fred. Good observation there. Good eye. But the answer is it's creating a new object and doesn't refer back to the original const. Okay. There we go. This was a tough day, but hopefully we can start to see that everything in JavaScript, really, at least the big functional pieces and inherited pieces, are objects by nature of prototypes, by understanding those things. So go look at your assignment after, go take an hour break. I'm serious, go take a break, come back, go through the assignments one line at a time. And again, don't watch the 2-hour video. Go watch the smaller video up here. Go watch the small video. You can pair program any day except a sprint challenge, so you can do whatever you want. There's a pair programming channel for Web 19. So I would recommend Web 19 pair programming channel. So if any of you are like nervous and you want to like work with somebody, hop in that channel after lunch, drop a line and say, I would love to pair program today. And everybody will, I'm sure there will be somebody else that would like to do it with you. Okay. Again, this was the top of the hill. Tomorrow's going to be so much more fun. I promise. I'm serious. So just take a break, come back. You've got this. All right. See you tomorrow. Bye.